All right, geometry students, this is a portrait drawn by Kendra, one of my algebra students, and it is a portrait of the same person as the portrait on the front. They're both of Maddie Howe. This one is apparently a portrait of when she was a baby. With So that's the art. Here's the math. You're going to graph and label the points and identify the quadrilateral. Explain how you know. That is, explain how you know what kind of quadrilateral it is. So we have A, which is 2, 2 right there. B, 1, -2 is right there. C is -4, 0. D is -3, 2. So those are the four vertices of our quadrilateral. So I'm going to connect those and form the quadrilateral. And there it is. So what kind of a quadrilateral is this? Well, I see that this side has length 5. And to figure out the length of that side, I can look at this triangle right here. And basically all I need to know is that the bottom leg of this triangle right down here, this is 5. And it's a right triangle, which means that the hypotenuse must be longer than 5. Since the hypotenuse must be longer than 5, that means these two sides are not congruent. And clearly these two sides are not congruent, so there are no congruent sides of this triangle. Now I'm going to look at the slope triangle to see if there are any parallel sides. In particular, are these sides parallel? And since my delta y is equal to 4 and my delta x is equal to 1, that means my slope is equal to 4 over 1. And over here, my delta x is equal to 1 and my delta y is equal to 2. So my slope is equal to 2 over 1. So since there are no congruent sides and no pairs of parallel sides, this is a common quadrilateral. Common meaning that it is not a special quadrilateral of any kind. All right. Now, on this one, um, you have to find the slopes and the side lengths that are given from those points. And I'd like you to pause the video and do that now. And I will then reveal all that information. So pause, please. All right, now you should be back. And here you go. There is all of the information about the side lengths and the slopes of the sides. And we're going to go on and answer these questions below. Are any of the slopes above parallel or perpendicular? Explain how you know. Be thorough and specific. Well, I see that AB has a slope of 1 and CD has a slope of 1. That means that side AB is parallel to side CD. They both have a slope of 1. And they are distinct. And we'll see that later when we sketch the grid and graph them. The next part says, what is the perimeter of this shape? Well, remember that perimeter is calculated by adding up the side lengths. Since all of those side lengths are estimates, our perimeter will also be an estimate. So my side lengths of 4.24 plus 6.71 plus 6.32 plus 6.71. When I add those up, the perimeter is approximately equal to 23.98 units. Now I'm going to put off answering anything about the area of the shape because we don't know what kind of shape it is. We know that we have one pair of parallel sides, and let me just go back to this other question. Are there any perpendicular sides? Well, side BC has a slope of -1/2, and side AD has a slope of -2/1. While they are reciprocal, 1/2 and 2/1, the they flip up, the fraction is flipped upside down. They are not opposites. Both of these two slopes are negative, so they're not opposite reciprocals, they're just reciprocals, so they are not perpendicular. So now we're going to just do a quick little sketch of these points down here. So here's my XY coordinate grid, and it's going to be a pretty rough little sketch. That's okay. So my first point is -8, 4. So -8, 4 will be about right there, let's say, and that is A. -5, 7 will be about, this is pretty rough here, about there. That's B. C is 1, 4. So that's going to be about, oh, right there maybe. It's got to be up a little bit. It's got to be the same Y value as A. So that's pretty close. And that is C. And then D is -5, -2. And that's going to be about right there or so. And I'm going to connect those. This is pretty rough here, real rough. What I do know is that AB is parallel to CD, so these are parallel. And I also know that BC and AD are congruent. Those sides are congruent. So this is a trapezoid because I have a pair of parallel sides and only one pair of parallel sides. So it's a trapezoid. But the other thing is that these two non-parallel sides are congruent. And this is known as an isosceles trapezoid. So it is an isosceles trapezoid, because it has exactly one pair of parallel sides and the non-parallel sides are congruent. So I know it's an isosceles trapezoid, and the next part that I'm going to answer is what is the area of this shape? And I'm actually not going to answer this. If this were a trapezoid where I easily could find the height here of the trapezoid, I could easily calculate the trapezoid's area. A trapezoid has an area, so let's see, the area of a trapezoid is equal to so let's call this B1, the base, and call this B2, the second base. So the area of the trapezoid is B1 plus B2 divided by 2. So that's the average of the two lengths. And then times the height. of the trapezoid. So you take these two and you average them, and then you multiply that by the height, which is the line's length that intersects at a right angle here. And the process for finding that involves you can find this length. You have these two lengths. So you could use the law of cosines to find angle theta here. And then by finding angle theta, you could then find this length which intersects at a right angle along with this side right here. But it is not, that's beyond the scope of what we're interested in doing here. So I'm not going to have you answer this right now. But know that that is the area of the trapezoid, and you're probably going to want to know that for the test eventually. So that is the notes for today. I hope that it all makes sense, and I look forward to continuing on with this work. Have a good one.